Welcome to another math exam paper 4 solution in our Cambridge Assessment International Education series. This is a completely solved Cambridge IGCSE Mathematics paper 4 extended for May-June 2020, and time allowed is 2 hours and 30 minutes. The total mark for this paper is 130. To help with time management, this is our suggested strategy. To earn 130 marks in 150 minutes, you need to spend about 1 minute or less per mark on average. The remaining 20 minutes or more can be used to fill out your candidate name, center number, and candidate number, read and understand the instructions. Quickly scan the paper and circle easy-looking questions which you should do first. Double-check your work at the end, especially the harder questions. If you push yourself harder and spend less time on the easier marks, you give yourself more time for harder questions. This is what you can expect from this video. A detailed explanation showing how to solve each question. A hands-on demonstration on how to make the most out of your calculator. Welcome! In 2018, Gretel earned $32,000. She paid tax of 24% on these earnings. Work out the amount she paid in tax in 2018. Highlight the amount and the percentage of tax. 24% is a fraction with 100 as the denominator, so we write 24 over 100 times that 200. Fraction 24. Denominator is 100 times 32,000 equals. We get 7680. In 2019, Gretel's earnings increased by 7%. Work out her earnings in 2019. Increased by 7%. If 100% was 32,000, 107% is 107 over 100 times 32,000. Fraction. Numerator 107, denominator 100 times 32,000. 34,240. 34,240. Gretel invests $5,000 at a rate of 2% per year compound interest. Calculate the value of her investment at the end of 3 years. This is a formula for calculating compound interest earnings. A is the value of her investment. PA is the amount invested. R is the rate of earnings per year. And N is the number of years. So we need to plug this in. 5,000 times brackets fraction 100 plus 2. Denominator is 100. Close brackets raised to power 3 equals, and we change that into decimal. 5306.04. We present that as 5306. 1 month, Gretel spent a total of $360 on presents. She spent a fifth of this total on present for her parents. For parents, she spent a fifth of $360. A simple calculation gives $72. She spent 2/3 of the remaining money on presents for her friends. For friends, 2/3 of the remaining money. 360 minus 72 is 288. 2 over 3 times 288, 192. We have $192 spent for friends. She spent the rest of the money on presents for her sisters. For her sisters, the rest of the money is 360 minus the total spent. That is 96. We are required to express this as a percentage of 360. 96 over 360 times 100. 96 over 360 times 100 equals 80 over 3. In decimal form, 26.6666 recurring. This is how to convert a fraction into a percentage. That fraction times 100%. So we write 26.7, 3 significant figures. Arjun earned, that is 6,515 in 2019. This was an increase of 9% on his earnings in 2018. Work out his earnings in 2018. So an increase of 9% over his earnings in 2018 means that this amount is 109% of his 2018 earnings. We need to work backwards to 100%. First, divide everything by 109 on the right hand side. Then to make 100%, multiply by 100. Everything on the right hand side by 100. That is 6,515 over 109 times 100. We get that at 3,500. Arjun and Gretel each pay rent. In 2018, the ratio of the amount each paid in rent was Arjun to Gretel 5 to 7. In 2019, the ratio changed to 9 to 13. Arjun paid the same amount of rent in both 2018 and 2019. Gretel paid $290 more rent in 2019 than she did in 2018. Work out the amount Arjun paid in rent in 2019. Let's multiply the top ratio by 9 to make it 45 to 63. The bottom one by 5 to make it 45 by 65. These two ratios are equivalent to the original ones. Arjun's rent never changed, but in this case, the number has increased by 2 units. So we can say 2 units is equal to $290, and 1 unit is therefore equal to $145. We need to find what Gretel paid in rent in 2019, represented by 45 units. 45 times 145 equals 6525. The heights H meters of the 120 boys in an athletics club are recorded. The table shows information about the heights of the boys. Write down the modal class. To get the modal class, we scan all the frequencies and pick the highest. The modal class is the low number and the top number. That is what defines the modal class. Calculate an estimate of the mean height. To estimate the mean height, we need the midpoints of each class of H. For example, in the first class, we take the low number 1.3 and add it to 1.4 and then divide both by 2 to get the average, to get their mean. So 1.35 is the midpoint of the first class. We do the same for all the other classes. Now that we have the midpoints, we take the formula for the mean height, which is the sum of the product of frequency and height, frequency of each class, and the midpoint in that class. We multiply them out, add them up, everything divided by the sum of all frequencies, which is the total number of boys. So we list them out. each midpoint with the corresponding frequency. Then we add them up, divide by 120. Fraction. Numerator 1.35 times 7, close brackets, add bracket 1.45 times 18, close bracket, add another bracket 1.55 times 30, close bracket, add another bracket 1.65 times 24, close bracket, add open bracket 1.75 times 27, close, add open 1.85 times 14, close bracket. Type denominator 120 equals 1.62333. That's our mean. One boy is chosen at random from the club. Find the probability that this boy has a height greater than 1.8 meters. Looking at the top end of the table, there are 14 boys in this class, the only one with boys taller than 1.8 meters. 14 out of 120 is the probability, which can be simplified as 7 over 60. 3 boys are chosen at random from the club. Calculate the probability that one of the boys has a height greater than 1.8 and the other 2 boys each have a height of 1.4 meters or less. This is a class of boys with 1.4 meters or less. Greater than 1.8, we shall call those ones tall boys, and we shall call the other ones short boys. To get a tall boy and 2 short ones, there are 3 ways to do that. We can start with a tall boy and 2 short ones follow, or short followed by tall and a short one, or starting with short and tall. Selecting a tall boy from 120 is 14 over 120, followed by a short boy selected from the remaining 119, followed by another short boy selected from the remaining 118. Or picking a short boy first is 7 over 120. Then we pick a tall one, 14 over the remaining 119. Then another short boy, 6 now remaining out of the 118. The other combination is select a short one out of 120, another short one out of the remaining 119, and a tall one out of the remaining 118. In probability, OR means add. So we can add all these 3 products. But a closer look reveals the top numbers are the same. They are just switched around. So adding this is just like multiplying one of them by 3. Fraction. Multiply the top numbers, 14 times 7 times 6 times 3, which is also a numerator. Bottom numbers, 120 times 119 times 118 equals. This is our answer. Use the frequency table on page 4 to complete the cumulative frequency table. This is the frequency table. The first 2 cumulative frequencies are filled for us. First one is simply the number of boys in the lowest group. Second number is that 7 plus the frequency in the second class. So to get our third number, we take 25 plus 30. Then we do 55 plus 24 to get 79. Add 27 and add 14. And the final number should be 120. That is how you know if you are correct. On the grid, draw a cumulative frequency diagram to show this information. The grid starts at 1.3. We know there is no boy with a height lower than 1.3. We mark 0. Less than 1.4, we have 7 boys. Less than 1.5, we have 25 boys, and so on. We mark all the 7 points, and then as smoothly as possible, we join the points together to complete our cumulative frequency diagram. Use your diagram to find an estimate for the median height. The median height is the height of the 60th boy, the middle boy. So we simply project 60 onto the graph and onto the height axis. We get 1.62. That is our median height. The 40th percentile. 40% of the total number of boys, 120, is 48. So the 40th percentile is the height of the 48th boy. We project 48 onto the graph, and on the height we find that it is 1.575. So the 40th percentile is 1.575. Question 3. S is given by this formula. Find the value of S when U is equal to 5.2, T is 7, and A is 1.6. Replace the quantities on the right side with the respective given values. Brackets here are just for convenience, but we shall key the numbers into the calculator without brackets. 5.2 times 7 plus fraction 1/2 times 1.6 times 7 squared, press equals, and change into decimal. We get 75.6. Simplify 3a minus 5b minus a plus 2b. Rewrite with the a's together and the b's together. 3a minus a is 2a. Negative 5b plus 2b is negative 3b, and it is that simply solved. Simplify 5/3x times 9x over 20. When we multiply fractions, we multiply out the numerators and then the denominators. So we get 5 times 9x, 45x, 3x times 20 is 60x. Then we simplify. Start by cancelling out the x. 15 is the highest common factor of these two numbers. We can divide both by 15. 3 at the top, 4 at the bottom. And this is our final answer, 3/4. Solve. 15 over x equals negative 3. Multiply both sides by x and we get that horizontal equation. Divide both sides by negative 3 so that the left hand side becomes negative 5, and on the right we only have x. The answer is negative 5. Solve this equation. Start by expanding the brackets. 4 times 5 is 20. 4 times negative 3x. We have 20 minus 12x equals 23. Subtract 20 from both sides. 23 minus 20 is 3. Divide both sides by negative 12. And x is negative 1/4. Negative 1/4. Simplify this indices expression. Let's rewrite this and separate 1/3 from 2/3. 1/3 and 2. A power of 1/3 means get the cube root. Cube root of 27 is 3. Cube root of x to power 9 is x to power 3. Let's now deal with the outer bracket, finding the square of the terms inside the bracket. 3 squared gives 9. X cubed squared is x to power 6. That is our final expression, simplified. Expand and simplify these two brackets. Create a quick table and put the first bracket horizontally at the top. Place the second bracket vertically on the side like that. 3x times 2x is 6x squared. Negative 5y times 2x is negative 10xy. 3x times y is 3xy, and negative 5y times y is negative 5y squared. Put the like terms together. The terms with xy combine to give us negative 7xy. Then we list these three terms out here. That is a simplified expression. Question 4. Transformations. Draw the image of triangle T after a reflection in the line y equals negative 1. This is the line y equals negative 1. Bring in a tracing paper, place it over the triangle T, and cover part of the line of reflection. Hold the tracing paper firmly and trace out triangle T. Trace out a section of the line of reflection so that it is on the tracing paper. Take the tracing paper and flip it over. Bring it back onto the grid and line up the line of reflection as perfectly as you can. This is where the reflected image will appear. So firmly holding the tracing paper, trace out this triangle so that when you take away the tracing paper, you will have an impression of the reflected triangle on the grid and you can trace it out. This is the image after reflection. Draw the image of triangle T after a rotation through 90 degrees clockwise about 0, 0. Tracing paper again. Make sure it covers triangle T and also the center of the rotation, the point 0, 0. Trace out triangle T. Draw on the tracing paper a line along the y-axis, holding the center of rotation firmly with a sharp pencil. Rotate the graph paper until the line has turned through 90 degrees. The image of rotation will appear in this location. Trace it out, and when you take away the tracing paper, you can trace out the new triangle, the image after rotation. Describe fully the single transformation that maps triangle T onto triangle A. Triangle T, triangle A. Exactly the same orientation, which tells us that this is a translation. To find the translation vector, let us use this point and count along x 1, 2, 3, 4, 5 until we are directly above the corresponding point in A. We count along y, this time negative. Negative 1, 2, 3, 4, 5, 6. Positive 5, negative 6 is our translation vector. Question 5. X is an integer. The universal set is a set of numbers between 41 and 50 inclusive. We can list out the elements of the universal set. These 10 numbers. A is a set of x such that x is an odd number, but within the universal set. Let's list out the elements of A. B is a multiple of 3. We can list out the elements of B. And C is a prime number. List out the elements of C. These are 3 subsets of the universal set. Complete the Venn diagram to show this information. Taking one number at a time, 41 is odd and prime, but not a multiple of 3. So it belongs to both A and C. 42 is a multiple of 3. It only falls in this set B, so it belongs to B only. 43 is another prime number. 44 is in none of these 3 sets, but it is within the universal set. 45 is a multiple of 3, and odd. It is in both A and B. 46 belongs to none of the three sets inside. 47, another prime number, which is also odd. 48, another multiple of 3. 49 is odd. It only belongs to set A. 50 joins the other two numbers, which are in neither of the three sets. That is our complete Venn diagram. List the elements of A intersection C. A intersection C is the overlap region between these two sets. The three numbers in there should be listed as the elements of A intersection C. List the elements of B union C complement. Don't miss that little symbol. It means once we get B union C, the shaded region, we need to look outside. Complement means look outside the shaded region. And we find these four numbers outside the shaded region. Find the number of elements of this set A intersection B intersection C. The overlap of the three sets, this shaded region here. It is an empty set, so the number of elements is 0. Number 6. Rahim makes baskets and mats. Each week he makes X baskets and Y mats. He makes fewer than 10 mats. The number of mats he makes is greater than or equal to the number of baskets he makes. One of the inequalities that shows this information is Y less than 10, which comes from this statement: he makes fewer than 10 mats. Write down the other inequality. Considering this statement, the number of mats he makes is greater or equal to the number of baskets he makes. Mats is Y, so Y is greater than or equal to X. It takes 2¼ hours to make a basket and 1½ hours to make a mat. Each week, he works for a maximum of 22.5 hours. Show that 3x plus 2y is less than or equal to 30. 2¼ hours times the number of baskets he makes represents the time spent in a week making baskets. 1½ hours times the number of mats he makes in a week represents the time spent making mats. Adding them up, we should get a maximum of 22.5 hours, so the total time should be less than or equal to 22.5. Let's multiply everywhere by 4/3. Here we get 3x plus 2y here, and here we have 30. This is what we needed to show. On the grid, draw 3 straight lines and shade the unwanted regions to show these inequalities. Here are the inequalities. Take the first one. Y is less than 10. We need to draw the boundary line. Y is equal to 10. The points on the line are not included because y cannot be equal to 10. So we draw a dotted line. Take any point on either side of the line, like 0, 0. The value of y is 0 and it is less than 10. The unwanted region is the region above this line, and we shade the unwanted region. The next inequality, y is greater than x. Boundary line should be solid because points on the line are included, and we should draw the line y is equal to x as the boundary line. Take a point like 0, 6, this one. X is 0, y is 6, so this point must be in the wanted region. We need to shade the other side of the line, which is the unwanted region. 3x plus 2y is less than or equal to 30. We need to draw a solid boundary line because the points on the boundary are included in this inequality. So we need 3x plus 2y is equal to 30. To do that, let's start by setting x is equal to 0. When x equals 0, 2y is equal to 30. So y is 15. 0, 15 is a point on the line. Let's set y equals 0 and we get 3x is equal to 30. X equals 10. So 10, 0 is the other point on the line. We only require 2 points to draw a straight line. 3x plus 2y equals 30. Question is, which is the unwanted side of this line? Let's take a point at random here. 6, 8. When x is 6, 3x is 18, and y is 8, so we have 16 here. 18 plus 16 is 34, and it is greater than 30. So this point is in the unwanted region. We proceed to shade that side of the line. We now have all the unwanted regions shaded. He makes a $40 profit on each basket he sells and a $28 profit on each mat he sells. Calculate the maximum profit he can make each week. This statement gives us the profit formula, which we can write here. 40x plus 20y is the profit he can make in a week. We need to find a point, a pair of values x and y, which will make this profit maximum. And remember, x and y have to be whole numbers, therefore we can only pick points with whole number coordinates. Let us first key in this profit formula into our calculator, then we can test several points. Profit is 40 alpha x plus 28 alpha y. That is our profit formula. The higher the value of x and the higher the value of y, the higher the profit should be. So we should generally look around this region to get the maximum profit. How much profit would he make if he made 6 baskets and 6 mats? With this formula, we need to press calc and enter the value 6. For x, press equals, enter the value of y, and we get the profit would be $408. We can test another point. 3, 9. So again press calc, enter 3 for x equals, enter 9 for y equals. Profit of $372, which is less than what we got previously. After a few tests, we found this point will give us maximum profit. So we shall key this into the calculator. Calc, x is 4, y is 9. The maximum profit is $412. That is our answer. Question 7 is on trigonometry. The diagram shows the positions of 3 points A, B, and C in a field. Show that BC is 118.1 meters, correct to 1 decimal place. Let's rename the sides for ease of reference. A, B, and C, and the angle in between is alpha. We are required to find this side A. We know the other two sides and the included angle between them. This is a perfect setup for the use of the cosine rule. So we write out the cosine rule with A as a subject in terms of the other two sides and the angle in between. Let's put in the numbers and also take the square root of both sides to give us A. We are trying to save time, and this is a good strategy in your exam. When you have to make a calculation, make it the last step in your working, so you pick the calculator only once. Key in the expression on the right side, starting with the square root. Put brackets 115 squared plus 80 squared minus 2 times 115 times 80 times cos 72. Always check to ensure the calculator is in degrees mode. Close brackets and close brackets again because we started with a bracket. Equals 118.0639119. which we round off to 118.1, and that is what we were required to show. Calculate angle ABC. We got our diagram here. Angle ABC is this one, ABC. Let's rename it as beta and label that as the angle we need to find. Looking across, we have the opposite side and another pair of an angle and a known opposite side. Perfect setup for the sine rule. Put sine beta as the numerator on the left side and complete the sine rule. Multiply both sides by 115. Let's make beta the subject so that we perform only a single calculation. So beta is the inverse sine or shift sine of this expression. Shift sine fraction sine 72 over 118.1 times 115 close brackets equals 67.8336 etc. We need one decimal place, so it is 67.8. The bearing of C from A is 147. Find the bearing of A from B. This is the bearing of C from A, 147 degrees. What we need is the bearing of A from B. Standing at B, face north, turn clockwise until you are facing A. That is the bearing of A from B. And this is the angle we need to find. If this is 147 and we are given 72, then this angle is 75. This north line and this north line are parallel, and we know that same side interior angles are supplementary. They should add up to 180. So we know this angle. We can find that this angle here is 105. If we subtract this from 360, we get 255 as the angle we need, and that is the bearing of A from B. Find the bearing of B from C. Let's start by placing this angle here. We just found this angle in the previous calculation. This is a straight line, and the only angle we do not know on the left side of the line is this one. If you do your math, all angles in a straight line should add up to 180. So this one must be 7.2 degrees. The angle we need is this angle made from north to this line. But given north lines are always parallel, this angle and this angle are both alternate angles and they are equal. So this angle is 7.2 degrees, and that is a bearing 7.2 degrees. Mitchell takes 35 seconds to run from A to C. Calculate his average running speed in kilometers per hour. A to C, we need to change that into kilometers, dividing by 1,000. 35 seconds needs to be changed into hours. We divide by 3600. So we have the speed formula, distance over time. 0.115 is our numerator. Divide by 35 over 3600. We get 414 over 35, but in decimal form it is 11.828 etc. We shall write that as 11.8 kilometers per hour. Calculate the shortest distance from point B to AC. From a point to a line, we need the perpendicular dropped from B to meet AC at right angles, and that is the shortest distance. This is a right angle. We know the angle, we know the hypotenuse. We can work out the opposite side, which is the distance we require. Let's call it h. It is equal to 80, the hypotenuse, times the sine of 72. 80 times sine 72. We get 76.1. That is our shortest distance from B to AC. Question 8. On the axis, sketch the graph of y is equal to sine x for x between 0 and 360 degrees. To make a reasonable sketch, let's take advantage of our calculator and create a table of values. Mod, press 7 and enter sine x, sine alpha x, close brackets. Press equals. We shall start with 0 equals, end at 360 equals. We can go into as many steps as we wish, but it is a sketch, so only a few points are needed. Let's go in steps of 90 degrees. Press equals. And here are the first 3 points, x, y pairs. 0, 0 is the first one, so we mark that on the graph. Then we have 90 and 1. It's an approximation because we do not have a scale. 180, 0, 270, negative 1, 360, 0. 180, 0, 270 and negative 1, 360 and 0. We now need to meticulously join these points in as smooth a curve as possible. Of course, we have an idea what a sine curve looks like. That's it for our sketch. Describe fully the symmetry of the graph of y equals sine x for that same range. If we rotate this graph around this point, 180, 0, we find that it can fit onto itself after a half turn. So there are two positions in which the graph can fit onto itself. So we say rotational symmetry of order 2, center 180, 0. Solve. For sine x minus 1 is equal to 2 for that same range. Let's start by adding 1 to both sides. 4 sine x is equal to 3. Divide by 4 both sides. Sine x is equal to 3/4. So x is the angle whose sine is 3/4. Let us find sine inverse 3/4. Shift sine 3/4 equals 48.59. We write 48.6 to one decimal place. But they are not satisfied. They are expecting another answer, another value of x. Let's take another look at the curve. If we draw the line y is equal to 3/4, a constant, we find it intersects the curve in two positions between 0 and 360. The first one is this one, the angle we just found by calculation above. There is another one before we get to 180 degrees. Apart from the rotational symmetry just found, the first part of the graph, 0 to 180, has some reflection symmetry about 90 degrees. We shall take advantage of that to find this angle here. If this angle is 48.6 from 0, it should be 48.6 degrees from 180 degrees. To get this angle, we must do a 180 minus 48.6, and that is our second value of x, 131.4. Write x squared plus 10x plus 14 in the form x plus a squared plus b. This is what we call the vertex form of a quadratic expression. This perfect square can be expanded, and this is the expansion. When we compare these two equations, the first two parts are okay. We now need to take this and add a squared to get a perfect square. So where do we get our a? Take the coefficient of x to a and divide it by 2. So the coefficient of x divided by 2 is 10/2. We add that here. But to keep the expression unchanged, we also need to subtract the same 10/2 squared. 14 should not be forgotten, so that this expression is equal to the original one. This middle part does not change the validity of the expression because we have added and subtracted the same figure. But writing it like this enables us to get two parts of the expression which we can simplify separately. This can be simplified to this form by just simplifying the bracket, and this is negative 25 plus 14. This expression now looks exactly like this one, and we can work backwards to where we started. So we can now take this expression and write it as x plus a squared. Remember, our a is 5, so it becomes x plus 5 squared. This part resolves, and this now is the required format in which a is 5 and b is negative 11. So that's our answer. On the axis, sketch the graph of y is equal to x squared plus 10x plus 14, indicating the coordinates of the turning point. This is the same equation we just wrote in vertex form. This is a very useful form because from it we can get the turning point, that is the minimum or the maximum point. In this case, we have a minimum point because it's a positive quadratic. This squared quantity can never be less than 0, and it will be 0 when x is equal to negative 5. So everything there is 0, and the value of y is negative 11. So a quick table, when x is negative 5, y is negative 11, and we can get not only the minimum point, but also the axis of symmetry of this quadratic. Let us set x equals 0, and this becomes 5 squared minus 11. 25 minus 11 is 14. So 0, 14 is also a point on the curve. We can now take advantage of the symmetry of the curve. We know this is the line of symmetry, and this is the minimum point. So 5 points to the right of the line of symmetry, we have a point 14. Let's move 5 steps to the left of the same line of symmetry to this point, and we expect y to be having the same value of 14 also because of the symmetry. And with these 3 points, we can do a simple sketch by just joining these with a parabola curve. And that will do it for our sketch. The diagram shows a sector of the circle with center O, radius 8 centimeters, and sector angle 165 degrees. Calculate the total perimeter of the sector. Perimeter consists of this arc length, the radius AO, and the other radius OB. 2 pi r is a circumference of the whole circle, but we only need a fraction of it given by the sector angle over the whole revolution, 360 degrees. So let's put in the numbers. This is the length of the arc AB, then the 2 radii. We need a calculator for this part. Brackets, fraction 165 over 360 times 2 shift pi times 8 and plus 8 plus 8. It gives 39.038. So 39.0 to 3 significant figures. The surface area of a sphere is the same as the area of the sector. Calculate the radius of the sphere. The surface area A of a sphere with radius r is given by this formula, 4 pi r squared. Let us get the area of the sector of the circle. Pi r squared is the area of the complete circle. We need the fraction given by the sector angle over 360 times the total area of the circle. That is the area of the sector. We equate that to the surface area of the sphere. Pi will cancel out, and this is the resulting expression. Divide both sides by 4, and we have r on its own side. Since we need r, we take square root of both sides. And we evaluate this with our calculator. Square root fraction, top number 165 times 8 squared divided by 360 times 4. We get root 66 over 3. In decimal form, it is 2.708 etc. We shall write it to 3 significant figures as 2.71. A cone is made from the sector by joining OA to OB. Calculate the radius r of the cone. Let's remember the arc length we just worked out above. This is the arc length. The length AB is now the circumference of the base of the cone given by 2 pi r, and r is the radius we are looking for. 2 pi appears on both sides, we cancel it out, and our r is given by the expression on the left. 165 times 8 over 360 gives us 11 over 3, but in decimal form 3.666 recurring. 11 over 3 or 3.67 to 3 significant figures. Calculate the volume of the cone given by V is equal to 1/3 pi r squared h. R being the radius of the base of the cone, h being the height from the center of the base to the apex. We worked out the value of r in the previous question, and we shall use it here in its exact form, not in its rounded form. 8 was the radius of the original sector, and now this forms a right angle. We can use Pythagoras' theorem to find the value of h. H is the square root of 8 squared, the hypotenuse, minus the square of the radius, the shorter side. No need to pick the calculator at this point, since we do not need h directly. We need to substitute the numbers in this formula for volume. 1/3 pi r squared times h. We now need to pick the calculator and evaluate this as the final answer. 1 over 3 pi times 11 over 3 squared times square root of 8 squared minus 11 over 3 squared. It gives us 100.105, but for our purposes 100 will do. 3 significant figures. A rhombus ABCD has a diagonal AC where A is the point -310 and C is the point 4, -4. Calculate the length AC. For ease of reference, let's call this point x1, y1 and the other point x2, y2. To find the length of any line segment AC between 2 points, we use Pythagoras' theorem in this form. x2 minus x1, the difference in the x values squared, plus the difference in the y values squared, y2 minus y1. Let's plug in our numbers and use our calculator. Square root brackets 4 minus 3 close brackets squared plus brackets -4 minus 10 close brackets squared equals. We get 7 root 5 or 15.652. In 3 significant figures, 15.7. Show that the equation of the line AC is y is equal to -2x plus 4. Our 2 points again. We start by finding the gradient of AC. The gradient of any line AC is the difference in the y values divided by the difference in the x values. Let's put in the numbers. We do not need a calculator here. -4 minus 10 is -14, and 4 minus -3 is 7. -14 over 7 is -2. We now use one of the points. Let's use the first one to express the equation of the line in this form. y1 and x1 are the known coordinates of the point we have chosen. Y and x are the general points, and m is a gradient. Put in the numbers. Open the brackets and add 10 to both sides, then simplify. -6 plus 10 is 4, and this is our final equation, which we were required to show. Find the equation of the line BD. To help our visualization, let's sketch our rhombus. We need to remember the diagonals of a rhombus are perpendicular bisectors of each other. That means they cut each other into halves and meet at right angles. The meeting point here, which is the midpoint of both lines, is given by the average of the coordinates of the 2 points. The average of the x coordinates, x1 plus x2 divided by 2, y1 plus y2 divided by 2. This gives 1 over 2 and 3. We need the midpoint as one of the points on BD, and we also need the gradient of BD. Since AB and BD are perpendicular, we can find the gradient of BD using this formula. The gradient of BD M2 is -1 over M1. M1 is the gradient of the other line, which we found. This is the relationship between the gradients of 2 perpendicular lines. We use -2, the gradient of AC, to find that the gradient of BD is a half. So now we have 1 point on the line BD and its gradient. We can use this point and the gradient to write the equation of the line, and it is this: y minus the y value, gradient x minus a half, the x value. Open the brackets and add 3 to both sides. When we simplify, 3 minus a quarter is 2 3/4, which is 11 over 4. So now this is the equation of the line BD. A curve has the equation y is equal to x cubed plus 8x squared plus 5x. Work out the coordinates of the 2 turning points. We need to start by finding the gradient at any point of the curve which requires us to differentiate the equation of the curve. dy dx is equal to first term derivative is 3x squared. Differentiate 8x squared, we get 16x, and the derivative of 5x is just 5. At a turning point, the gradient is always 0, so we equate this to 0. It is a quadratic expression which we can solve by factorization. Within the two brackets, we need 3x and x because that is the only way to factorize the first term. We need two numbers whose product is 5. So let's introduce 1 and 5 and test if they give us the middle term. 3x times 5 is 15x, x times 1 is 1x, and they add up to 16x. So these are the factors of the left-hand side. We equate that to 0. It means either the first bracket is equal to 0, and when we solve, we should get x is equal to negative a third. That will be one of the values of x we are looking for. Or we equate the other bracket to 0 and solve. We need to plug that in to the place of x. We have the x coordinates of the two turning points. So how do we find the y values of the same points? We get back to that equation and substitute the values of x one at a time. So to find the y coordinate when x is negative 3, we plug in the value of x in this equation. We need our calculator here. Let us type out the equation of y, alpha x cubed plus 8 alpha x squared plus 5 alpha x. To get the y value, we need to press calc, enter the value of x, negative 1 over 3. It gives negative 22 over 27. So that is the value of y when x is negative a third. We then substitute x equals negative 5 in the same equation to find y corresponding to this x value. So the formula still in place. Press calc, enter negative 5 as the value of x, press equals. We get 50, and that is the value of x. We have the coordinates of the two stationary points. Determine whether each of the turning points is a maximum or a minimum. Give reasons for your answers. We worked out the first derivative of the curve, which gave us the positions of the stationary points. We now need to differentiate this expression again to get the second derivative. 3x squared differentiated gives us 6x. Differentiate 16x to get 16, and differentiate 5, it gives nothing. 6x plus 16 is our second derivative. On our calculator, let's write the expression of the second derivative. 6 alpha x plus 16. Take the first stationary point, key in the value of x in this expression for the second derivative. So calc negative 1 over 3 equals 14. So the second derivative is 14, and it is positive. It's not the value that's important. It is whether it is above 0 or below 0. When it's positive, it is a minimum point. Take the second stationary point. Plug in the value of x into the expression for the second derivative. Calc negative 5 equals negative 14. So second derivative is a negative number. So this point is a maximum. Reason? The second derivative is negative. Congratulations! You've made it to the end of this long paper. If you would like more solved math exams, please subscribe to this channel and hit the notification bell. You will get notified every time we post new content. In this channel and in our Maths Homeschool online website, you will find lots of free maths content with worked examples. The links are in the description below this video. Thank you for watching.
Watch the next video. Share with a friend. Subscribe and hit the notification bell icon. Thank you for watching.